You can title this lesson Fractional Distance. It's just really a follow-up from our other lesson, Fractional Distance. So today we're going to find the distance, but we don't want to go all the way. We want to go 1/4 of the way, or 2/7 of the way, or 3/9 of the way. Well, that was reducible to 1/3. But anyways, we don't want to go all the way. We want to go a fraction of the distance. So that's why today's lesson notes are titled Fractional Distance. A biker is biking along the trail that resembles a number line. Pretend like he's training for the MS 150, a popular fundraising bike race in Houston. If the starting point of the trail is at -12 and the ending point is at 20, how far has he traveled if he's only biked 1/4 of the trail so far? So he hasn't even made it halfway. He's got a long way to go. What should we do first? Should get our pen or pencil out, and we should find the distance. I totally agree. But for this one, since we're just starting, let's draw a picture first, okay? He starts at -12, and he needs to get to 20. So this is his start. This is his end. I agree. We need to find out how long this course is. That's going to be step 1 every time. Find the distance. What is it? Everyone type it. Go. The answer is 32. Very nice. So the distance from the start to the end is 32. Let's call it miles, even though they didn't give us units. Okay. That's step 1. Find the distance. Step 2 is multiply by whatever fraction you are given. Multiply by 1/4. And you have permission to type your answer. Go. It's the same as dividing by 4. Very good. Good. I'm just putting miles here, even though the problem didn't say miles. I like having units. It bothers me when I don't have units. So that's the end. This one only had 2 steps. We found the distance. We multiply it by the fraction. How far has he biked? How far? He's biked 8 miles. Okay, now we're going to add something onto it. It wasn't really a warm-up, but okay. So the biker from the previous problem, let's name him. What do you want to name him? Joe Bob. Okay. So Joe Bob has invited a friend to come with him. Joe Bob has a friend named Freddie. Yep. Okay, so we got Joe Bob and Freddie. His friend is late. He was running late. He forgot his water bottle. He came late. He needs to find exactly where Joe Bob is. And remember, Joe Bob has already completed 1/4 of the trail. Where is Joe Bob? What coordinate is Joe Bob at right now when Freddie arrives? So we're adding one more step on to what we did. Let me summarize what we did so far. The first thing we did was we found the distance. If I were you, I would write this in my notes. He traveled 8 miles. He's not at mile marker 8. That's not the coordinate where he is. That's how far he traveled. So to find out where Joe Bob is, we need to take the starting coordinate. Here's my start. And we need to add 8 to it. -12 plus 8. Travel 8 in the positive direction of the number line. And where do you land? -4. So I'm going to say, I'm going to do add or subtract, because sometimes you have to subtract. Distance to the end point. Well, no, that's deceiving. I'm going to put to the start. So the last thing you do is figure out where did he start, and you add the distance to whatever the starting point is. Okay. We have 2 examples, and then we're done. What is the coordinate of a point that is 4/9 of the distance from A to B? I'm going to go quickly. Step 1, find the distance. That will never change. Find the distance. Distance is, we learned it already. The distance is 27. I don't want to go 27 units. I want to go 4/9 of the distance. 27 times 4/9. When you put this in your calculator, make sure you put parentheses around the 4/9. When you put that in your calculator, oh, you can't see because of the glare. Make sure you put parentheses around it. Very good. It equals 12. The biggest mistake my students make is they put 12 as their answer. 12 is not the answer. It says from A to B. From A to B. So we're starting at A, and we need to travel 12, but we're going in the negative direction. So take 21, which is your starting point, and subtract 12. Final answer. So the coordinate, the answer is 9. Is that okay? The last example of the day, we're going to do this, but not one-dimensionally. We're going to do it two-dimensionally. Here we go. Find the point that is 1/4 of the distance from A to B. We're going to do the same steps we did, but we're going to do it to the horizontal, and we're going to do it to the vertical, because now we've got a rise and a run, not just a run. So what we're going to do first is find the rise and the run. 1, 2, 3, 4. The rise is 4. 1, 2, 3, 4, 5, 6, 7, 8. I just found the distance. I found delta x and delta y. I found the distance between 1 and 5 and the distance between 1 and 9. I found the distance. Now, step 2, we multiply it by the fraction. And our answers are so beautiful. 8 times 1/4. That means our new run is 2. And our new rise is 1. So it's saying start at A, rise 1, run 2. We did the same series of steps as before. Sure, you can put the answer. Rise 1, run 2. What is our answer? Is our answer rise 1, run 2? No, it said find the point. So we need to actually name the coordinate of the point. 1, 2, 3, 1, 2. Someone asked me, this is my wrap up, someone asked me, well, what if they're asking me to do this, but I don't have the coordinate plane? How would I know where I end up if I don't have a graph? And that was a great question. We started at 1, 1. Our new rise was +1, and our new run was +2. So if you didn't have boxes to count on the coordinate plane, you could use your starting point A, and then you could use your new rise and your new run, and you would get at the right answer without having a grid. 3, 2 is right. Okay.